Okay, guys.
All right. So, how's everyone doing today? The weather's good outside. Hey, it's nice. It's starting to warm up. It's not cold anymore. So I think everybody probably knows me. I'm Michael, VP of Engineering here at CloudSpace. Thanks for coming out. Thanks for being part of the community. If you have any questions, obviously I'll be around. Feel free to stop me. I noticed that we've got a couple of cool members of our Ruby community out here tonight, so good to see everybody coming out. It's good to see Jeremiah again. But Caitlin will give you guys all the announcements and everything that go on. And other than that, enjoy. Thanks for coming out.
All right. So real quick, next week we have this lovely oddball meetup called CSS. That is a random one, by the way. We'll see if we make it something regular. Who knows? RSVP would get here early. We already have 53 people RSVP'd for that. Oh my goodness, yeah. And I have three speakers for that already. So I do not need any more speakers for that. Aside from that, we have Tech Week coming up April 13th through April 18th, ending with Bar Camp, which is pretty awesome. Make it out to that. If you want details, let me know. I have all the details. But randomly in the middle of Tech Week is a lovely thing called a JavaScript meetup that we do once a month, second Tuesday. That's going to be a special one. It's going to be an all-women speaking JavaScript. I have 3 women speaking, and I am one of them. I'm literally starting to build something this week for that meetup. So, yeah, it'll be interesting. So come out to that. That's another one that we are expecting to be massively big. You can come in at 6 if you want to. Try not to come in before that, though. You're fine. You're okay. That way we don't disrupt the office, but otherwise you guys are more than welcome to come in early. That way you get a seat. Well, there'll be plenty of food. Don't worry about that. But other than that, we buy the first round of beer, a rolled of beer after, so definitely stick around. I think everyone here is 21. If not, get a soda or water or something. World of beer, we'll check that. But other than that, we are good to go. But Jimmy, would you like to start?
Sure.
Okay. Oh, by the way, we do live stream this, and it is on YouTube. It's meetups on YouTube. So
I will suck in my gut the whole time.
So that's why I have the mic in my hand, so that
okay.
way they can hear you on YouTube.
All right, that makes sense. Okay. Do this. I'm figuring. Why did I fucking invite you? All right. Great. So, plug in.
And I'm going to post the link
There it is.
stuff in the meetup group. If you guys are not a part of that, it'll be next.
So, I am Jimmy Secretan. I am the VP of Engineering at Sonobi. So, I'll be talking about machine learning in Ruby, or how to build a Terminator in your favorite language. So, full disclosure, Sonobi is not a Ruby shop. We do Python stuff, but that's okay too. I am a sort of a Ruby guy at heart, but I can live in that world as well if I must. But yes, the Sonobi people are it's a cool company to work for. I will plug a little bit. We are always looking for great talent who can think well with data. So if you are such a person, then let me know, and we'd love to have you in and meet you and talk to you and all those other nice things. But all this Ruby stuff, obviously this is all me, just from Jimmy Secretan personally. So hopefully you might find it interesting. So I'm going to talk about usually when you think of like machine learning and data mining, like people don't always think of Ruby. Shame, because there's so many things that it's good at. It's a language that I've really learned to just enjoy. Like, it's fun to use Ruby. So, and I think it's sometimes they're just historical accidents that, some things kind of grow up in Python, and okay, Google has adopted Python, and then it becomes data intensive, and then there you go. So But I think Ruby has a lot to offer that in terms of and so there's a lot of reasons why you would interface with Ruby, whereas that might not generally be the go-to language. So I want to talk about some of those reasons tonight, and then just give you some examples. They're very rough examples. Don't expect to be deeply impressed, but it's stuff I find cool and like to talk about. So why would you do this in the first place? So there's a lot of really good reasons. Just first and foremost to integrate some machine learning and data mining into your app. It's not necessarily anymore the kind of the realm of sheer hardcore data science. There's a lot of really easy off-the-shelf things that you can and you should be using. So there's a lot of good ways, for instance, to bring smarts to your app. So product recommendations, those are those are big one, or content recommendation. Anything like that, that's if you have a Rails app already, there's a lot of great ways and reasons you should be integrating, some kind of content understanding. There are businesses who kind of rise and fall by the smarts of their content recommendation engines. I think HuffPo, I don't know if it's in Ruby on Rails or whatever, but the content that you see is they are very smart systems around that to optimize ultimately what you're going to get. So if it's content recommendation around A/B testing, if it's something that okay, I'm optimizing driving conversions or something like that. You have a conversion page and you want to there are, for instance, cool apps that will rearrange themselves, using evolutionary algorithms to optimize to a click-through rate. So there's all sorts of cool things you can do now that you have access to those off-the-shelf algorithms. Prediction and scoring of just about anything. So there can be one thing that usually comes up is so there's credit scoring, right? And it sort of works in around this whole world of machine learning and data mining, because ultimately they're trying, when you think of a credit score, right? Ultimately they're trying to predict, okay, here are some different things we know about this person, and here's if we think they're going to be a good credit risk or not. And there's a lot of cool applications like that, So take the users in your system. You can identify users that you think are going to be high value. We do this all the time in the world of advertising. So Sonobi is an ad tech company, and we work on, in a lot of cases, we're showing how user data and engagement is driving ultimately the outcomes that people want to have, whether it's clicking to something, going to something, spending a lot of time on the page. Ultimately, you guys to figure out, take logs or whatever you need to, or doing it in real time of scoring. Okay, actually, here's what we think predict this user will do next. Here's the kind of user we think this is. There's again all these great off-the-shelf ways to to start to incorporate this. Intelligent agents. So there is you can make awesome games in Ruby, and I think you should. And there's some tech that I'll show you that's kind of neat on that you can use to ultimately drive intelligent agents, for instance. So smart little virtual robot people that that can go around the worlds and do different things, take different inputs, ultimately interact with the user in some way, have that interaction, not. So there's sort of the whole world of natural language processing that, you can do some cool stuff with and get into some relevant things there. But, even over and above that, okay, well, they see, you think of stuff like Quake. It's actually it's not very hard to train a bot like that with some simple inputs. They see where you are, the direction you are, and if you have a dozen inputs, it's not difficult to actually train a little robot to know where to follow you, where to shoot, all those kinds of cool things. And then ultimately, really on the practical, something like a real practical side is, and something that back Correlate, that later became JD Power, we did a lot, which was using Ruby as a glue language to try to drive forward, some of our really data-intensive stuff. So we would have a lot of processes that even if they were run in, that used the Hadoop stack, or we did stuff in Pig, let's see what else, or they were driving large MPP databases used Greenplum, which is like a massively parallel data. Lets you run. It'll have like 10 different servers, and it'll store like billions and billions of records, and then you ultimately run SQL, sort of analytics SQL queries against that. Ruby ended up being a really great way to drive and direct all of that process, using some other things as intermediary data stores. So it's great, and again, people don't usually sort of seek it out for like really numerically intensive stuff, but it really is a good language to sort of glue all that together. So we'll have some examples of kind of all of these. One that's worth talking about, and I'll show a little sort of example of how this will work. So there's interfacing with R and Ruby. So a lot of it just comes down to, okay, what level of sophistication can I put together like to interface stuff with? So it's like, yeah, it doesn't necessarily make sense that you ultimately have to re-implement everything in Ruby or get libraries that re-implement everything in Ruby. So there's stuff like R. So R, awesome piece of open source statistics software. There's a lot of things it's good. It's good at. People use it for, they'll set up different like machine learning and data mining problems in there. So, they'll do like recognition things. Okay, here's again my like credit risk data set, or my set of users who are, some ended up being very like high value and engaged that I want to make offers to. Some are just, they log in for the free account and I never see them again. And how do I offer deals and identify like ones that are really great versus ones that are not so good? And there's just so much built-in stuff into R that you can interact with that you can like already take advantage of, that it makes a lot of sense to have a interface with it. So there are actually a few different interfaces that you can use, and then basically the idea is you just pass some data back and forth where it makes sense. You'll take stuff out of the database, or you'll take stuff from user input, and then you'll ultimately just send that over to R. So here's a little example. Let's see how good this looks. Right. So this is thank you. So this is kind of how it would look. So it's pretty simple to use. There's the R in Ruby gem. You basically, and what that does is it makes a constant R that you can send stuff through to eval. And you can pull, you can push data into it, and you can slurp data back out of it. Simple data. But ultimately, it's going to, so this is loading a library for a priori rule mining. So this is for, like frequent item set stuff or market basket analysis. The thing they usually talk about when they say, oh yeah, they looked at the Walmart data, and when people bought diapers, they also bought beer because their children drive them nuts, or whatever reason that they subsequently give. But so you can imagine like a lot of those things, like association rule mining, being very useful to find like, okay, well, what are in my data or for my users, what are the sort of interesting little things that I don't know about them yet? So, basically all you have to do is shove commands into it through an eval. I will do that for you. Is that tiny? Oh yeah, that's super tiny. Oh. So yeah, now you can get all this like super advanced stuff that will come out of it, and ultimately, like those algorithms are actually, so they're generally done in C or C++. They're like well optimized toward the model there. People have done a lot of work into R, and then you're just taking advantage of that interface and putting a little bit of data into it, and ultimately getting the model out. Okay. So there's a lot of good external services that can be, of course, like, yeah, if it can be driven through something RESTful, it can be driven through Ruby. But there are lots of things that I think took really good advantage of Ruby as a glue and scripting language. So something that was my favorite, which is sadly defunct now, is Mortar Data. I would love to see. So they had an open source gem that was able to interact with the service. And really, it was just for running Apache Pig stuff. So if anybody's not familiar with Apache Pig, it's basically just a really cool data-oriented scripting language that runs on top of the Hadoop stack. So you can have, instead of writing like a whole Java, whole Java program that's around like, oh, okay, yeah, map and reduce this stuff and writing that code, it was basically, okay, here's some simple scripting languages that has, some useful primitives of like, okay, take this data out, transform it in a way that would be sort of like familiar to, say, a database or something like that, and ultimately write it back out somewhere, to HBase or to S3 or whatever. Excuse me. But it's definitely worth pulling that gem and taking a look at it, because it was really neat. In the way it would, it would interact with AWS on the back end and like bring up the servers that you need and automatically submit your script and like pull out debugging information. So I would love to see somebody like do something with that and put a nice hosted service on top of that. But another good one that I played around with a little bit is BigML, and so they have like a nice kind of Ruby interface that really just goes on top of their RESTful interface. But it's it's worthwhile. So you're going to see my secret API key there. Please disregard it, because there's super secret stuff in there. So don't look at it. Here, let me pull that up. Let's see. Oh, here. So yeah, this. So BigML is it's designed around like really simplifying kind of the whole machine learning process, and it is machine learning as a service basically, and they write a nice Ruby wrapper for it. So this is actually a really good alternative. So they have some data sources, for instance, that they use for prediction. So the iris flower classification, which is totally bitchin' and is super exciting. It's like an old 60s data set where they would use the length of different parts of the flower to determine what kind of flower it was. It is extremely exciting in the fast-paced world of data mining. But there's more relevant and cool data of like, okay, yes, predicting sales of different kinds of wines based on different properties around it. Yes, predicting whether you would be a Titanic survivor based on different properties or about you of like, yeah, what was your gender? Were you in steerage? Were you painting a nude picture of Kate Winslet? Were you king of the world or whatever? And the let's see, car accidents or actual medical data sets. So there's a lot of cool stuff to get you started with. These are kind of a lot of these are the go-to data sets in machine learning and data mining, and this is like a really good way to get introduced to this whole world of stuff. So basically, you can just upload source data, make it into what's called a data set, which it'll just do you basically dump out that source data and it's going to do some analysis around it. And then you can, and actually you can do a lot of this stuff through the web interface if you want to set up, you don't have to, of course, train everything or do everything through Ruby. You can set up a lot of that data. So say you do have a list of, okay, here are users that I've labeled. Here's 1,000 users who have come to my system, and who turned out to be a valuable, good user, and who turned out to be a shitball. And basically, you can take that, upload that into here, run it against a lot of different models. So to say, oh, okay, I've already done some classification against it. I've used so here's just like a simple decision tree it made out of it. And so it's saying like, oh, okay, well here was different, here was different stuff around it. Here we can, that ultimately let me determine like, okay, what kind of user this ended up being. And then really all you have to do is you can say, oh, I need to pull out that. I've already done all this great work on the back end, pulling out that model and training that model. And now when a user signs up, I'm just going to make a call like this. I'm going to connect to it first, and I'm going to pull out the model that I already know I've trained for it, give it some input data that's basically, okay, what do I know, this user who's signing up for the first time, what do I know about him or her, and predict, okay, do I need to show them these cool offers because I think this will be a super high value, high income, great user, whatever, or no, this is probably just a bot, so don't do anything. And yeah, you can. There you go. This is my totally awesome display of that I didn't have time to do anything but inspect this, but it'll essentially give you like, oh, okay, this was the category, so this would be, and here's the confidence that's associated with it. So those are the important parts of, yeah, okay, and the classifier will say, yes, I think this is a very good user, and it's great. You pluck that information back out, and you go do something useful with it. And you can ask me questions if you guys want or care.
Sometimes these guys talk a lot, and sometimes they don't.
Thank you for not lying.
Which shocks you. Sometimes they're really loud, and you're like, hey, awesome. And then other times they just don't speak over.
So there are a handful of libraries that do some native machine learning stuff in Ruby, and I don't think that's such a bad thing. I think performance is getting to the acceptable range now. I think and I think there are a lot of good machine learning primitives that they're like really fit well into like a Ruby DSL, and so this is a good example of something. Ruby Neat. So NEAT standing for Neuroevolution of Augmenting Topologies. It's something there's a professor dude at UCF, Ken Stanley, and that was like his big research focus, and now it's like a really well-known algorithm in neuroevolution. And the idea pretty much is that the algorithm like generates some population of tiny neural networks, like 3-node neural networks. How am I doing on time? Am I?
Yeah, you're good.
Okay, good. Like 3-node neural networks that, so if it is something, we've used it to generate images, or if it's driving a bot or something like that, it's driving a little avatar. Okay, so here's the inputs, of like, okay, here's what the I see, here's what, the direction of your enemy or whatever, and here's the guns that you have. So we'll start with those inputs and make very simple connections to the outputs, and it'll do what's called complexifying. So part of the evolutionary mutation that it'll do is it'll actually pack on complexity and make bigger and bigger networks, which they showed through researchy things that was actually a lot better way of sort of exploring that, concept, like that evolutionary space of brains, pretty much. That if you start simple and then complexify, you actually sort of get to where you want to go a lot faster. So it's a totally neat algorithm. I studied it for like a long time, and I liked it a lot. But there is an implementation of RubyNeat. I didn't write an example, but I will shamelessly steal an example that they made. Oh, no. Wrong one. The letters are tiny now. Okay. So basically what they start with in this is they say like, oh, it's a toy problem that they use. All right, can a neural network figure out how to do an exclusive OR calculation? Right? So it starts this simple, but it can go to anything as complex as you want it to be. Like, okay, yes, did my agent ultimately learn to, shoot everybody in the game, or whatever you want to evolve this brain to do, or did it learn to recognize different images well, or whatever your measure of success with. Of course, in like any evolutionary algorithm, all you need to do is give it a fitness function where you say, okay, this is ultimately what means you will be successful. So, well, here for the neural network, you define input. There are a number of like different little settings that you can tweak about the population, and then here's where you let's see, and then right. You calculate the fitness by saying like, okay, I know this is what an exclusive OR looks like. How close did the neural network get when I tried to make it do that? So you just have to define this fitness function that is whatever success that you want. was it the most, based on the data set, was it the best combination of page attributes that ultimately led to that? In your game, was it, the guy who could, ultimately outsmart the player the most number of times? Whatever that is, you basically give it that and a way to, cost and compare all that stuff. And then ultimately, it will run. I'll do a big, complicated-looking run. Oh, and so now it's showing you. It gives like the critters. Calls them critters. They are technically phenotypical expressions of the genotype, but critters is fine too. So they give the critters all names, and they're saying like, okay, I'm evolving generation after generation, and here's the fitness. So I think in here they use a fitness function out of 4. Like 4 is you did the job perfectly. These guys are, close to the mark. And as soon as it finds, it'll either stop at a number of generations when it finds something that's good enough, or it just gets bored and doesn't want to do it anymore. Or it, or if it basically reaches what is essentially a perfect solution, it'll let you know. And so you can do, let's see, neaters. Anyway, you can do some really cool stuff with it. And I was telling some people previously, like, we had used this back at the university to, we basically made neural networks that generated images, and you could evolve those, and it was super cool. Sadly, this was not done in Ruby on Rails, but I wish to do it. I would love to do it all over again in Ruby on Rails with all this neat stuff that now exists. This was back in like 2007 when we had basically primitive tools, and we were like software cave people. But and so ultimately, here, did that go to a thing? So you can do cool stuff. This again is not Ruby, but there's no reason it couldn't be. That you can basically evolve little agents that go around and accomplish whatever you want, and you essentially kill the ones that are not very successful at doing stuff, or you put this is a game, Nero, that was based off of Neat. You can basically put like gun turrets around and stuff that they should evolve and learn to avoid, and eventually, there's a lot of cannon fodder, but sooner than later, they kind of learn to do all the right stuff. I won't bore you with the rest of that. So there's some other interesting stuff that I found. Like Ruby Band was it seemed like a pretty cool, mature gem that interfaced with Weka. So Weka is like a well-known Java machine learning library that's got it's got like a lot of cool functionality in terms of filtering stuff out. It's a little bit easier for developers to work with than say like doing stuff in R, because that's a whole different way of thinking. And they have a really nice interface to it too. Prediction.io is one thing I was getting into based off of Spark and HBase. So of course anything where you can do JRuby interaction too, you can sometimes there are nice things that interact with Java stuff, because a lot of that sort of large-scale machine learning and data mining, it's coming from the Java world. So we can have our cake and eat it too. We can take advantage of what exists and the performance that's there, and not have to develop in Java, and we're very happy people. So that's about it. Yes, William.
So when you're doing the R stuff, what would be the primary reason you would want to wrap R, or a couple reasons why you would want to wrap R in Ruby? If all you're doing is r.eval, why would you still do this?
Yeah, that's a good question. So basically, for instance, what we do now, our data people, our like statistical data people, or data science guys and ladies, they are real comfortable in stuff like R. So they, that's what a lot of those departments end up using. So it ends up being a really good way. I mean, moreover than just taking advantage of, okay, I need to do some a priori, an a priori algorithm, and I don't want to implement it in Ruby. Oh, look, and nobody else wanted to either. Oh, look, I can just grab it from there. Besides that, a lot of those departments and people like they actually want to make those models in R, and then it's just like, oh, okay, well, yeah, just clean that up a little bit, and I will take that out and sort of integrate that into the rest of the application, and that's a good way to do it.
Okay, cool. So you already have a Ruby application, you just want to throw the R into it, and it lets you test it. And
Yeah.
Okay, cool.
Yeah.
Fitness thing that you ran.
Yeah.
That you said it was going to go to 4. Does that ever get to 4? I was surprised it took so long.
I know that was a pretty dumb one. I think they do get to 4. I've seen experiments, not with Ruby Neat, but I've seen Neat experiments. It definitely gets to 4. Sometimes it takes a leap of insight
That was
to
only
get to 4.
300 generations. So how many generations would it normally take, do you think?
I don't know. I think the paper, like you can actually find a paper with this for real answer, but
Okay.
and admittedly, Ruby Neat doesn't have like the best performance. Like that probably should have taken, a lot less time. But it's a good way to experiment. Like the original C++ implementation probably would have reached it in, let's say, 30 seconds.
It could have been maybe an old version of Ruby or something.
No, it's a new version of Ruby. I think there's a lot of stuff that they still have to optimize, admittedly, and that's why like a lot of people don't do native stuff. I think there are good ways to organize it such that you can,
Yeah,
yeah.
but these are really fast. Like that's never been an issue. But
That's fair, but yes, it will reach perfect fitness. It will figure it out. It is not that dumb.
yeah, because the C++ one you're talking about, that's on your laptop, right? It will do that in 30 seconds.
Well, this was like on like computers like 8 years ago.
Yeah.
Like they would. So I just don't think this one is super optimized. But it's very like they actually wrote a nice DSL that's like cool to experiment with if you want to get into it.
Cool. Thanks.
All right. Thank you. Here you go.
Go next.
Oh god. Tangled everything.
All right. Let's hope your stuff connects cooperatively.
It'll totally mess up.
Trust me, we've had plenty of technical issues. You can do either or, regular HDMI or the other one. I don't know which one's better for you.
I always plug it in over here.
Okay. You have an HDMI port too. That's
Okay, sweet.
Let's see. Let's see. Does it like you? No.
Okay.
Okay. It's between
Regular
the 1080.
HDMI. All
Well, it's
right.
also depending on
Oh.
the.
Maybe we'll just do the HDMI.
Try that, and then if not, we'll play with your refreshed settings.
Okay. So it's my fault you're saying. It's my fault I got here so early.
And then we never played with it. Yeah, it's okay. Yep, we got to play with it.
Okay.
So go into your display settings. We've had this happen enough that I actually pretty much know all of this. So it's one of the 1080. You need to go to 30 hertz. Oh, they're only 50. Doesn't make sense.
Built-in Retina. Hold on. Maybe I'll turn mirroring on. Can I do that and have it work a little
It's
bit?
one
No,
of-
that's way worse.
Where'd my Joey go?
That's
No.
not better.
Do you know this
there's
one?
a 30 hertz.
Ha 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 ha.
But it's still
Still jacking up.
crazy. Crazy tough.
What are the options you can do?
So some of these have like the cooperative options, and then some of these don't. But it's one of the 1080s.
Can you configure it all in one direction? You can move my laptop if you want to use it.
Sure, that
There's
could
some
work
data.
too.
We've played with this before. I just
It
don't
should
know.
optimize for that guy. What? I mean,
Playing 2 players.
yeah, it's like it's scaled. Oh,
Ah ha 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 ha.
There you go.
I knew there was there's two 1080s that pop up.
okay, maybe 720.
Oh, you shouldn't have to.
Yeah, you should have a good 720.
Because it's supposed to be one of the 1080s that works.
Mm.
But one
wanna
of the
do both.
1080s is also goes and changes the hertz rate.
Oh, okay. Okay, so
So-
maybe if I go 1080p and then
And then
go
change
over
the
there.
hertz.
Yep.
Haha. Okay, so 30. So give it a second.
Yeah,
Oh, there's
yep.
230.
Go to
There's
the top.
230.
There you go.
Don't ask.
There you go.
Got
You
it.
rock. You rock.
For not
Gosh,
being-
what would we do without you? I mean, all the engineering degrees and all the world in this room, and we probably never would have figured that out.
The
Okay.
architecture major is the one figuring this out.
Yes, exactly. Okay.
It's just, I've been dealing with this since September. This is just,
Par for the course, right?
yeah. It's sunsetting with the type of production that we have. The Windows is the worst. If you have a Windows computer, I might slightly just make you use one of ours.
I was about to have to use his, so that would have worked. Now I got to pull up my notes. Okay. Taking notes on Jimmy's stuff. Where am I thing? That's a video game. Okay. Very good. So, hello everyone. Sorry about the technical difficulties, although I'm sure it wasn't any of our faults. It's just whoever made this video card and that projector. So those people are going to die later. My name is Billy Watson. I'm the lead engineer for JD Power, whatever that means. I work on stuff every day. I'm not in meetings, and it's a pretty cool place to work. We work on big data stuff all the time. We're doing it in Ruby. As Jimmy said, a lot of it is Ruby as a glue language, Ruby to write pig scripts. But then some of it is JRuby running on Storm. So it's Ruby that actually does the processing. It's just compiles down to Java bytecode that can run on the JVM. And a real quick note on that for those of you who haven't ventured into this data stuff. The reason why a lot of it's written in Java is because the JVM is fantastic. Java is the problem. The JVM is not a problem. Clojure is increasingly being used for some of this stuff. Java, Scala, JRuby now. So I'll show you some of how we do our stuff. Primarily, this is an overview of stream processing in general to get you just introduced to the topic, and then talking about the different ways you can do stream processing, the different platforms, and then we touch on Ruby. So, and there's some jokes about how little Ruby there is in this Ruby meetup talk. But stay with me. It is very good information, I think. It's information I wish I had 3 years ago getting into this. So first, to talk about stream processing of data, you have to talk about data. So imagining, for instance, in my thinking brain, with my ridiculous metaphors, that your data is a bucket of water, and that bucket could be an ocean, it could be a lake, or it could be literally a tiny bucket. If you've got a startup, maybe you don't have much data. If you have a startup like ours was, maybe you've got a ton of data and you don't have a ton of money to process it. Now, imagine how you would process that data. Typically, a lot of people think of batch processing. They think, I'm going to put my data into a dump truck and I'm going to dump it on some people for an ALS challenge, right? The metaphor breaks down. But it works for water. That's how you would transport water to its final destination. You put it into a truck, and then you drive the truck someplace, and then you dump it. In breaking the metaphor down for a minute, imagine you've got some data in a database, right? Typical setup. Some sort of database could be something as simple as SQLite. It could be something as complex as HBase. And you need to get that to its final destination. Its final destination could be a chart, a CSV file, another database, just some sort of UI someplace, whatever it is. A batch process would do this when someone hits a button, when in a cron job. It would look over all of the rows. Netflix does batch processing in Pig, and they do it on 2 petabytes of data. Correlate, JD Power Odo, we do it on 2 terabytes of data. You could be doing it on 2 megabytes of data. Whatever it is, that's a batch process. Scoop up the data, do something to it, and ship it. Stream processing looks more like this. It's slightly more complicated. Because the goal in stream processing is to do it live. That's typically the goal. As the data comes in, do something to it, and then ship it out. Twitter does this all the time. You can't do it on one tweet. There's too much overhead, but they batch it into, say, like 50 tweets. And so 50 tweets, and they get enough data coming in that if they just wait, a few milliseconds, they've got 50 tweets, no problem. So then they take those 50 tweets and they transform it and they ship it to a number of different databases. The primary database, last time I read about it, was in HBase. You would take that data and you store it in multiple locations. So if you've got a giant HBase cluster across thousands of nodes, there's no need to wait. Oh, I'm going to write it to that node, and I'm going to write it to that node, and I'm going to write it to that node. You can write to them in parallel. It's a little easier to do in a stream processing platform. Back to our metaphor for just a second. Let's say, and thank you Toro for this image, and your giant logo. You've got your reservoir here. And back to the dump truck thing, imagine that reservoir is still there. It's still your source of data, but a pump truck comes in, pumps that water out, pumps it into the dump truck, and the dump truck drives away. A little bit more complicated in the stream processing. It goes through chemical injection tanks, some filters, and we can leave the rest of the crap out. And then, obviously it has to be pumped out of the ground and all that stuff, and then sent to its final destination, these plants, not a bunch of people standing in a field waiting to be dumped on for an ALS challenge. But never mind, it doesn't matter what the destination is, the thing is the same. So for stream processing, in processing of data, we call it ETL, extract, transform, load. Take the data out of the reservoir, transform it somehow. In this case, we're cleaning it up and we're filtering it, right? Those are things you do to both water and data. And then you send it to its final destination. Again, a database, a CSV, UI, a plant, whatever that is. And again, the goal is real time. And there's a few things to think about. Parallelism. You can see there's not just one chemical injection tank, there are 3. There's not just one filter, there's 4. Why would there be 4 filters when there's only 3 injection tanks? The tanks are a little bigger, the filters may be a little slower, maybe that's just how Toro sells them, I don't know. But you need more of them to keep up with those chemical injection tanks. And I don't know, actually, it does look like the filters are after, but so you have to think about parallelism in a complicated stream processing platform as individual parallelism. If you have, like Jimmy was giving very simple examples of machine learning. If you have a very simple thing to do, maybe your parallelism is the one thing you need to do with that data. You just need to filter out some bad rows as they come in. You've got some web logs, and you don't want to act on the bots, so you just need to filter out the bots real quick. That's it. I just want to do that live, filter out the bots, and then show an ad. You can do that with stream processing. Data locality is another issue. You can see here that they chose wisely not to put the chemical injection tanks on the other side of the field from the reservoir. The pump that sends water into it is close to the reservoir, and the chemical injection tanks, which is the next stop for the water, they're also close to the reservoir. You have to think about this with your data. Maybe not in the beginning, but when you get to 2 petabytes of data as Netflix has, or even at the couple terabyte range that we have, you really have to think, how close am I to this data? Am I really going to want to ship this data across the internet? Probably not. If I can process it on the node, I'm much better off. And that's one of the concepts of Greenplum, the MPP database. Jimmy mentioned more of you may be familiar with Oracle. Even if you haven't used it, it's like, oh, millions of dollars. There's a reason why you spend millions of dollars on that database. And one of the primary reasons is data locality, is you can have the data on the machine and you can process it through a SQL query at the same time. In the real world, as data gets bigger and we want to get to real time, SQL queries don't work. And that's when the need for this sort of stuff comes out. But data locality was important 20 years ago, and it's important today. And the final thing you have to consider on the big topics, there's a million things you have to consider, obviously, is compute intensity. again, back to the filters versus the chemical injection tanks, it may be more intense to filter out water versus injecting some chemicals into it and sending it on its way. Maybe another reason why you have to have 4 of those. One of the things that you have to be concerned about with compute intensity is that you are not accidentally causing extra compute intensity. Something we can talk about later, but essentially you have to be concerned about something as simple as initializing an object. You wouldn't think that plus equals and 2 left or 2 less than signs in Ruby were any different. If you have a string, it's my favorite example, so for those of you who've heard me speak on this before, I apologize, you've definitely heard this example, but if you have a string and you want to append to it, you think, well, these are equivalent, right? Plus equals versus if I set A back equal to B, and I just say, oh, let me just append to it that way. A is still BC in both scenarios. However, plus equals instantiates another string in the meanwhile. And the left shift, the 2 left parentheses, does not instantiate a new string. That is 550 times slower. So it's the little things that make a huge difference. That could make you have to spin up another server, 5 more servers, whatever the case may be. Maybe it's not processing the data in time until you can afford to spin up a new server. Whatever the case, primary filters and chemical injection tanks and servers are not always cheap. Now, sometimes your processing goes awry, and all you end up with is a really pissed off wet cat instead of a nice growing field. Your processing may go awry for a number of reasons, including the aforementioned data locality and compute intensity things. Maybe you didn't think about them quite right, and all you've done is gotten water into your kitchen instead of getting water into your field. And that's okay. There are things to help you out. And when I say things, I mean platforms, processing platforms. There are paradigms that have been well established for stream processing, and luckily the guys at Twitter, Nathan Morris specifically, before he ever got to Twitter, figured out how to process tweets very quickly. And you can use, now it's called Apache Storm, for a lot more than processing tweets. But this is the very simple architecture. To continue with the water analogy, and then almost immediately throw it away, Twitter calls the data readers spouts, and then for some reason they send those to bolts. Don't really quite get that terminology, but you can see it divides the data up into tuples. I say tuples. I hear a lot of people say tuples. It's probably tuples. And you can see that in a storm topology, you can have many spouts, many bolts, one spout sending the same data to multiple bolts, and that data ends up at its destination. Its destination could be a bolt that doesn't have anything tied to it, as in this case. You've got 2 bolts that do something with the data and don't send it on its way. So you can imagine that these guys would be individual database writers. One's writing to Redis and one's writing to HBase. There are different types of topologies. There's a DRPC topology. We won't get into that. There's Trident, which is really cool. For those of you who are SQL guys, which I think most people I meet know something about SQL, Trident can integrate nicely with SQL, so you don't have to completely rewrite your entire system. If you've got a SQL query that can steal some data, then you can toss it into Trident. And of course, you can always, even before Trident, you could source data out of SQL. This Trident makes it a lot nicer. And it's not just SQL, but querying, data querying is built into Trident. The problem with Apache Storm up until a year or two ago is that the partitioning is very complicated. The data locality is very complicated to set up. So that third bullet point, or second bullet point, one of the most important things, data locality, Storm didn't do it very well. Which wasn't a big concern for us. We still have many storm topologies that we run today, and we'll keep running them for a while. But if I had to do it all over again, and I could do it today, I would probably choose SAMSA. SAMSA is very tightly tied to Kafka, which is how many of you know Kafka? Okay, so the guys presenting know Kafka. Basically, a lot of you know queues, right? Like we had them in school. So it's when it says message broker, it's a set of queues. So you have one queue can go to many people or many endpoints. Kafka can track that, so it knows not only not where things are in the queue, but where each individual reader of the queue is in the queue. So you can have the same data being read by multiple sources. This allows you to set up one SAMHSA topology and do batch processing and stream processing on the same data with the same code. Right now, if you were to just use Storm, what we do is we have a pig job that does some batch processing on the data and a Storm topology that does some stream processing on the data. It's kind of a pain in the neck, to be nice about it. Again, back to the data locality, Kafka partitions the data for you. SAMHSA knows what Kafka's doing, to put it at a very high level, and it can take advantage of that partitioning for you. I'll just comment real quick on the art. This is from a guy who works at LinkedIn, which are the purveyors, if you will, of SAMHSA. And he's an excellent presenter. He presented on this. This is also his art. And this is from a presentation I saw him give in New York. The last thing I'll say about Kafka and SAMHSA is that SAMHSA is inside of Yarn, and you can see the elephant. That's the Hadoop elephant. You can do MapReduce inside of Yarn. Yarn essentially allows you to. Yarn is really where a lot of the partitioning comes in. The communication with SAMHSA to say, oh, this is where you should run your processing. Kafka sits outside of Yarn, but using Yarn, you can align that partitioning. MapReduce that Jimmy mentioned is really sort of on its way out, and other things are coming in because of Yarn. But you can still do processing in MapReduce. You can do the stream processing in SAMHSA, and you can do it all on your Hadoop cluster, all on the same servers, essentially saving you money. And you can read that data out of Kafka or wherever you want. Redis, doesn't matter. SAMHSA can do that stuff. Storm can read it out of wherever you want. But if you use Kafka and you use SAMHSA and you use Yarn, you get a lot of benefits out of the box. And again, data locality is nearly free. I say nearly because you still have to think about how to partition your own data. Kafka's not just going to perform magical spells. You've got to program the thing. But once you do it, you're good. After I just sort of bashed Storm a little bit, the Storm on Yarn project is alive and well, as far as I can tell. Yahoo put it out so that Storm is a little more up to date with being able to run on top of Yarn and get that data partitioning for free. But you can see the sort of setup. You have in the you probably can't see my mouse very well, but you have the Yahoo Storm client and the Yahoo Storm server and the backtype Storm, the base Storm UI with the base Storm supervisors. So you have this weird mix of code bases going on to make all of it work together. I'd like to contribute to this open source project and get it merged in with the main stuff. But it looks like a giant pain, and I'm not sure I have all the time to do it. But some other guys who are probably smarter than me anyways are working hard on getting these things, why did I do that, combined so that hopefully all of us can take advantage of Storm on Yarn one day soon. The point is, data locality is important, performance is important, and real-time updates are hard. Not to depress you, and the other point is, Storm is written in Java and Clojure. SAMHSA is, guess what, written in Java. So what are we to do? Well, let's talk about some other frameworks real quick, and we'll hit on how this relates to a Ruby meetup. You have Twitter Hummingbird, which allows you to write Storm topologies without writing Storm code. and execute that same code on something that's not a Storm topology. So you can pivot tomorrow and you can say, oh, I don't want to use Storm anymore. I want to use this. And Hummingbird will send that same topology makeup to that other thing. And there's something else that's integrated tightly with, I can't remember the name of it, but it's kind of nice. Parsley Stream Parse, I was telling Jimmy about earlier. For you Python guys, or if you know Python people, Python is really nice for Ruby guys because it's very close. You just have to be careful about your indentation, your tabbing and spacing. But Parsley Stream Parse is written in Python. It allows you to, again, related to Storm, run a Storm topology without writing Java code. You can write Python code, and then you can also run that topology native in Python without running in Storm at all. There's Spark Streaming, which Jimmy briefly mentioned Spark. Spark is a giant project that has Spark sort of MapReduce, batch processing. It's not MapReduce, but it's batch. They have streaming. They have some machine learning stuff, and it's all sort of tied together. Spark is coming along big in the community. People are talking about it everywhere. Spark is another candidate, huge candidate. I would consider Spark Streaming and Storm and SAMZA to be the top players in this market. There's also Google Millwheel, which I can't say growing up as a Filipino, but the project looks neat and it sounds neat. I can't find the code anywhere. I have no idea. Google sounds like they did a great job on it. If you know how to run any of this stuff, you just send me an email and I would be happy to experiment with it. Apache S4. I don't know why they took over the Storm project when they already had S4. Maybe because S4 sucks. Also written in Java. I don't know that it sucks. S4 could be great. Just haven't used it. It sucks. Okay. Stradio Streaming, no idea what that is. The point is, from here, there's a lot of these frickin' things. Just to give you that's about half of what's available to you if you're doing streaming. Let's talk about some of the other half. So, no, this is not a Ruby meetup. Apparently, because I've just spent like 12 slides talking about things that aren't Ruby. I'm just kidding. Seriously though, this is a Ruby meetup, and we should talk about Wukong. So Wukong is really neat. It allows you to do, if you haven't seen the canonical example of data processing, it's word count. You've got some words in a file or in a database, and you just want to count those things. You want to count how many thes, how many billies, how many whatever. So it's two parts, and it really works well in MapReduce because you've got a line of text, and you split that line by word, and then you count them. And you see here you have a splitter and what they call a normalizer. In this case, they're actually not counting. They're just lowercasing everything, substituting, stripping of something, I don't know, and then only yielding it back out if there's still some stuff left after it cleans it up. So this is similar to a word count. This example using a nice Ruby DSL, that's what Wukong can give you. As Jimmy said, primarily the main benefit of Ruby isn't so much performance, although it's getting there. It's the readability and the development ability, being able to spin up developers very quickly and get them working on making you money. Or spin up yourself quickly on making yourself money, whatever the case may be. Sadly, this looks like a dead project. It hasn't been contributed to on GitHub in almost a year, so I consider that dead. However, never give up, never surrender. I just watched this last night, that's why it's in my head. It is a fantastic movie. You wouldn't think Tim Allen could do it, but it was a great movie. I did like the Santa Claus too, actually. It's a guilty pleasure. Of course, it's on GitHub. Wukong is on GitHub. You can take that project over. The code is very easy to understand. And if you need to do some stream processing tomorrow, You don't even have to take over the whole GitHub project. You can just download it and use it. But if you start to use it more, you can easily just take that over and maintain it and move along. And there are other options too, options that we chose. Anything that can be written in Java, pretty much, can be written in JRuby. I put 3 stars by that for a reason. One, I don't actually know that is true. I've done enough JRuby to be. We've put a bunch of stuff in production, but I can't claim that I've written like tens of millions of lines of JRuby code. I've written 1,000 or a few thousand lines of JRuby code. It's been working so far. 2, maybe you don't want to do that. maybe sometimes it's a bad option. And then there's a 3rd star just because it's Java. Like, just be cautious. But to that end, Redstorm is what we use at JD Power. And this allows us to write storm topologies and do it in Ruby, in JRuby. And we're able to ship out native JVM bytecode, Java bytecode, if you will, that processes, I think at one time off of one server, we were doing somewhere upwards of 1.5 billion records a day off of one EC2 server. So like $2 an hour. So $50 a day, you can process a few billion records. So it's performant enough, for sure. And you get, again, typical Ruby, you get a really nice DSL. Now, the 2 guys in the front row who work with me at JD Power maybe have a little bit weird look on their face because they're like, this doesn't look like the code we have. We chose not to use the DSL, but Redstorm still provides you a lot of really neat, package that code up and ship it and run it locally so you can test it and all of those nice things, test-driven development. And it's still Ruby. It's still far less Java-y when you're writing these Ruby classes, even if you don't use the DSL. And one of the primary reasons, just since I mentioned it, one of the primary reasons we didn't use the DSL is that on-receive and on-init aren't the same as the storm topology. So if you're looking at, or the storm terminology, so if you're looking at storm code and then you look at the Redstorm code, you might be a little confused. So we chose, okay, let's just skip the DSL for now, and we'll just go with what they call it, which is execute, initialize, execute, and finalize, which isn't even up here. But so I really like Redstorm. I like stream processing. Again, there's a million options. You may have to do it yourself in JRuby if you're wanting to use Samza. I'm not entirely sure how you would do that in Ruby out of the box. But if you're wanting to get into it, Storm, Redstorm, JRuby, and you're on your way in really a few seconds. Any questions? Okay. That's it.
So really quickly, while you disassemble and we get you set up, I'm going to let Susanna talk really quickly about something going on at Iron Yard.
Okay.
Make
Get
sure
all
you'll
this.
mic.
Sure. Oh, I was going to take it home.
Well, they'll be able to listen to on YouTube until I stop streaming. So here, I'll let you have this real quick, and then we'll get your laptop set up. Will you talk? Go ahead.
Okay, for those of y'all who don't know me, my name is Susanna Miller. I'm the campus director at the Iron Yard. We are a 12-week intensive code boot camp that's in downtown Orlando. We are starting next Thursday a series of 3 free crash courses in Ruby. So those should be actually a pretty great introduction to the language if you're just interested in learning more about it, or if you're at this meetup because you already know all about Ruby, but you know someone who might be interested in learning more about the language. Those will be taught by our very own Brian Gates. He's here tonight. He's our Ruby on Rails instructor. So those will be starting next Thursday. If you're interested or you know someone who might like to learn a bit more about the language, they are free. They'll be starting next Thursday night at probably 6. Still finalizing the time, but they'll be at our location downtown. Okay, and we do have a demo day coming up on Friday for our current classes. We'll be presenting their front-end and Ruby on Rails projects at the Exchange building downtown. So if you're interested in that, grab me afterwards.
Woohoo! Thank you, my dear. All right. Sorry, guys, once again. And we figured it out with yours, and then
Yes. So scaled.
scaled.
Right?
Click scaled.
And yeah, 1080p, and then on the other thing, you want to set to the second 30 or the first 30 hertz line.
Ha.
The default is okay. Very good.
Yeah.
There you go.
And there you go, Chris.
Quite good.
Thanks for putting up with our little
Isn't that the background they gave you?
This is my sweet desktop, guys.
That is awesome.
Are they vomiting unicorns?
No, they're obviously breathing fire.
Oh.
Yeah.
Oh.
Well, that's right. That's what you have to draw.
Oh.
Not the presentation. So, as my desktop depicted, my name is still broken.
Why did it?
Okay. Oh.
It cooperated for a second.
Microsoft on Mac, on projector.
What is it doing?
Works on my machine.
That is so weird.
Can you try the not maximize?
Say what?
Like the not full screen maximize, maybe? There's such a thing.
No, the presentation because it wants you to.
Yeah. You can just fudge it and then that'll work.
Can you guys see that?
Yeah.
Rock and roll. So my name's Chris Stamates. I'm the Director of Data and Analytics over at IZEA. I want to thank Jimmy for having me out to speak and inviting me to come out here, telling me about 3 days beforehand when it was. Cloud Space for having us out and getting the food, and then all of you for sort of sticking with us and sticking around here. I wanted to talk about one of the problems or one of the opportunities that we're looking at and we're facing at IZEA. You know, sort of the first thing that I should probably say is that I'm not at all a Ruby programmer. This is the first job where I'm really encountering the language from a production point of view. And it's not really my role to mess with it, really, at all. As was pointed out by the previous speakers, a lot of the ecosystem that you deal with data and analytics happens in Java or happens in languages on the JVM. So let's talk about this thing. What I'm really going to talk about is something called microservices and how you might end up doing that with Ruby. And for those of you who know your Greek, that little weird U-looking thing in front of Ruby is the Greek U for mu, which typically stands for micro. So who knows what a monolith is in software engineering, right? So you think of I like this picture because monolith is this big giant piece of software. And it's typically the way I think that most software projects start. But when you start to look more closely at this rock, right, which just looks like this big giant object, you notice that there's a lot of actual different things going on there. There's multiple layers. Those layers all serve their own purpose. But if you were standing back far enough, you'd mistake it for all one big giant piece of software. And I think from at least my limited experience with Rails is that Rails really kind of promotes this way of application construction. Again, I'm like super new to Ruby, so I'm going to use Ruby and Rails quite interchangeably throughout the presentation. There's two reasons why I feel this way. One is if you open up the app folder under a Rails project, right there staring you in the face is your views folder, your controllers folder, and your models folder. The way I look at those things is rendering, business logic, and data access, right? And the software engineer and software architect in me says you should always separate your view from your business logic, and you should always separate your data from your business logic as well. The other thing is is really the associations that Active Record does for you. Now, these are also the best parts about a Rails app, right? Is that it makes it very simple to get up and going very quickly with an application in production. But down the road, when you have the need, it makes it very hard to separate these things out into smaller pieces, which is exactly the motivation that I have right now. So this is maybe what we're looking at here. I'm using this big giant Hadoop icon to sort of symbolize big data processing portion of the stack here. But let's say we've got a core application. It's a Rails application, and so it's sitting on top of its database there in the middle. But now we want to start pointing data processing at it. We want to start pointing a mobile application at it. And we have some internal tools that up to now may have been integrated very, very closely with the core application. But because we don't want those deployed alongside our production app, we want to start splintering those things off as well. So how do we take these things and start breaking up the monolith, start taking the different layers of that big rock, separating them out, and providing APIs to them to allow all of these things to communicate effectively. And particularly for mobile, right? The view layer that's rendering our core application, that's just not going to work on mobile unless you've been super diligent about sort of a responsive design on the front end. But even then, you're probably doing your mobile customers a disservice by trying to give them the same experience that they have on the web on their mobile device. So maybe our architecture can look something like this. And I apologize probably with the way this is going here. Zoom in a little bit more. So maybe we put we break that big chunk up, which you can still sort of see here, into smaller bits. We've thrown an API up in front of the mobile application. We still have our view and our controller logic from the big application there in the middle that our core application is talking to. We haven't necessarily touched that, although I'd argue that over time you'd want to migrate that to your API layer as well. And then we've taken sort of these core concepts out of the monolithic app, the users, the accounts, and the metrics, and turn those into their own services that have their own databases. And this is really a key point that we'll get on here, is that in a microservice-based architecture, which is what this is starting to approach, it's very important that the individual services themselves manage the API to and the data access for the data that they manage. So now our internal tools can actually be separated off. Let's say that's a customer service tool that's interested in managing user accounts and seeing information about those. It only needs to talk about and know about the user's microservice. So let's maybe talk a bit more about a microservice. These definitions are sort of adapted from the work of Martin Fowler, who's sort of one of the thought leaders on this. I would encourage you to check out his blog on this kind of stuff. But really, a microservice is a software component that's independently deployable, replaceable, upgradable, and has clear exclusive ownership of its data. So it's other things too, but this is meant to sort of understand that it's behind an API. It doesn't matter what language it's written in, and we can upgrade it, we can enhance it to our heart's content, just so long as we don't break the contracts between it and all of the clients that are talking to it. And so a microservice architecture is a set of these components that work together to build higher order things like a full-on product and communicate through a high-level protocol. Being pretty vague here in saying a high-level protocol because REST works, HTTP works, any sort of messaging protocol works just fine here, just so long as the dependencies are reduced and they're not talking in an in-process fashion by directly calling functions. So what does microservices not mean? Microservices and software-oriented architecture, while certainly related, that's what SOA stands for in this slide, certainly related, but not necessarily the same. Service-oriented architecture applies just as well to in-process software architecture. Different components of that monolith talking to other components of that monolith, as much as it would apply to a microservices kind of view. It also doesn't mean Java, though I'll admit that there's quite a bit of tooling for services out there. Again, they don't communicate through in-process or in-memory mechanisms, so if everything's behind an API, all that matters is that you can serialize and deserialize from that message transfer protocol, be it JSON over REST or whatever. Docker, so again, Docker is used a lot when talking about microservices. I would encourage you to look into this, but doing microservices doesn't mean you're doing Docker either. Docker is simply a way to package your application along with the operating system and all of the software dependencies that application requires into a unit that can be independently deployed. Cloud and DevOps, it doesn't necessarily mean that either, though DevOps certainly will help you out with microservices, and this concept works just as well in the cloud as it does on an on-prem data center. And then maybe most importantly, a microservice is not defined by how many lines of code are in it, how many classes are in it, how large the executable is, or how well-defined or fine-grained the concept that it represents is. This is really sort of the art of a microservices architecture, is breaking it down into components that make sense for your team and your applications. So when should you maybe think about taking your monolithic application and breaking it up into microservices? The following points really here are adapted from a talk given at AWS reInvent by a guy from Netflix called named Sudhir Tants. And these are really just his bullet points that I'll repeat to you guys here. Is large code bases with many coupled components, and then specifically tied with bullet point 3 here, where you need multiple teams and multiple platforms to access that data. If you remember our example up here, right, and our monolith, certainly I think both of these apply. We have a lot of things going on in the core here, and we have multiple teams. We have an analytics team, a mobile team, and an internal team, and a core team that all need to get at that data. So that's a check. It's hard to confidently make changes. And then I would also sort of add to this, it's hard to be confident in the changes that are made. You think about how important it is when you hire somebody to bring them on and have them start making changes and deploying code to production extremely fast. The time that it takes for someone to do this in a monolithic style architecture is long. People, going back to the other point of how big is a microservice, how many lines of code, best answer that I've seen to that is it's big enough to fit in my head and understand sort of completely at once. And then the speed and innovation of deployment. If you've got a test suite that takes 3.5 hours to run, it might be time to start thinking about breaking that up. So, can you do microservices with Ruby and Ruby on Rails? And I would say, of course you can, right? There's absolutely no reason why you can't. I was having a discussion just before the talk about how it's really nice that Rails, you can take parts that you want, you can take parts that you don't want. You can take that view layer and just not use it, right? Or you can use it and you can use something like JBuilder to return JSON for you, or you can use Active Record Serializer, which seems to be the thing that everyone who seems to know more about Ruby, which is everyone, says to do. So these are sort of my recommendations from what I've read and from what I've gathered from talking. If microservices is an architecture style that you might be interested in your Ruby on Rails shop, these are the things you might be thinking about and keeping in mind. And first one is make sure you need it, right? Because there's nothing wrong with the monolith. If you're writing a simple tool, you're writing a very simple web app, manages relatively little amount of data, you can move fast with it, keep it. There's no reason to, because all microservices does is redistribute the complexity. It's not a silver bullet. It doesn't solve every problem for you. I would sort of encourage you to make sure and be really strict that every service manages its own data. As soon as you have a microservice that reaches across lines and reaches across databases and touches others, through active record associations or otherwise, you've broken the model, because now you have potentially multiple writers to a logical view of what that service is supposed to provide. Now, keeping in mind here that the active record associations are still okay, you can still use them. Just make sure that they're done between tables that are logically managed by an individual microservice. If we're not talking about a controller layer or a view layer as a service, eliminate the HTML views from your microservices. Personally, I would go a step further and say eliminate all server-side rendering from your applications and embrace front-end framework. But I understand that that's a holy war that I don't necessarily want to get into. And then the bottom point is, hey, Rails may not be the right tool, but Ruby certainly still can be. There's a couple of other frameworks out there that I've looked into a little bit. Grape and Praxis are two that sort of seem like they have some lifeblood to them, and I thought it'd be worth mentioning. And so I figured I'd end the talk there, and open it up for questions, but also encourage you guys as we sort of go and grab a beer. If you have ideas on this topic, I'm learning this as much as I am up here telling you about it. So please come seek me out and tell me how crazy and dumb and stupid I am. That's it.
Any questions, guys?
I have some tips after.
Sure. The one big question that